Hey, this is a video for 6.5, fossil fuels. So go ahead and check out the overview and set up your guided notes. So before we can talk about fossil fuels, we have to talk about fossil fuel combustion. And combustion kind of happens in a similar fashion. I'm showing you the combustion of methane, which is the molecule that is most prevalent in natural gas. So methane is CH4, one carbon, four hydrogens. When you add heat in the presence of oxygen, it will release a lot of energy. And also waste products are carbon dioxide and water. So this is a general formula showing you the molecules. This is how it would look written out. This CH is really just a hydrocarbon. So this can be methane. It can be also any hydrocarbons that are found in the other fossil fuels. Now you will see a diagram like this, and this diagram is the basic layout of the setup to conduct electricity or to generate electricity from fossil fuel combustion. So the first thing you need to do is you need to combust these fossil fuels. In this furnace, it will heat water and turn it into steam. That heated water will then travel over to a turbine, and it will spin this turbine really fast. The turbine is attached to a generator. So the turbine, when the turbine spins, the generator also spins. And this generator is just a series of magnets that are spinning in revolution. And when these magnets are spinning, they're causing a flow of electrons. Anytime you have a flow of electrons, that's electricity. So again, electrons flowing, now you get electricity. And the electricity is sent out to the grid. Now you're also going to have some superheated water that you need to send out to a cooling tower. And a cooling tower is an area with a lot of surface area to allow this heat to dissipate into the atmosphere. You cannot add this water back into a river or a lake because it will be very heated, and it will cause less oxygen to be dissolved in the water, which can lead to many issues with aquatic organisms, most notably thermal shock. And we'll talk about that in future videos. Now, in this process, you are taking mechanical energy from the spinning of the turbine and the generator, and you are converting it to electrical energy. You cannot just say spinning a turbine generates electricity. The turbine is attached to the generator, and that causes the electricity generation. You also will have chemical energy that is in the carbon molecules, or the carbon bonds in these fossil fuels. Okay, so you have chemical energy, mechanical energy, and electrical energy, all present in fossil fuel combustion. Now, some pros and cons of coal. Coal is only around 30% efficient, which means when you burn the coal, you're not getting 100% of the energy. Some of it is given off as waste. Coal is incredibly cheap, and that's because we have it widely available. Remember, the United States is a global leader in coal production and coal reserves. Coal requires little refining. Most or all of the refining has pretty much been done by nature, with the millions of years of pressure is basically concentrating the carbon atoms into the coal. It is also the dirtiest fossil fuel. So it has the most carbon dioxide, but it also releases a lot of sulfur dioxide, which is a major contributor to acid precipitation. It also releases particulate matter, which can impact photosynthesis, for example, if it gets into the air. It can also impact our lungs, causing respiratory illnesses. And it generates a lot of ash and soot, and this ash contains toxic elements like mercury, lead, and arsenic. And we'll talk about their impacts in future videos. But for the most part, mercury and lead will lead to neurological damage. It affects your brain. And also mining the coal, which we talked about during the last unit, but mining has all of those potential impacts, and it is a major disruptor of habitats, especially if you have mountaintop removal mining. Now, petroleum has some pros and cons. Petroleum is around 40% efficient. It also is more energy dense. and it's very easy to transport. Maybe not as easy as coal, because coal is a solid, petroleum is a liquid, but petroleum you can also transport it in a pipeline as well, so that gives it a lot of ease. It does have a potential for spillage. If it spills, like we've had some major disasters in the past, if it spills, it can coat the fish gills, making it virtually impossible for them to breathe. It can also coat birds' feathers, making it impossible for them to fly. So this can be very disruptive for biodiversity. Also, when you're constructing these pipelines to transport the coal, it can fragment the habitats greatly. And if anything spills, it can also contaminate the groundwater, which is a human impact. And finally, petroleum, not as much as coal, but it still does release pollutants. It releases carbon dioxide, like all fossil fuels, but it can also release sulfur dioxide, mercury, lead, and arsenic. Now, natural gas is 60% roughly efficient. It is the cleanest fossil fuel. It's also ideal for heating. It provides less energy per unit volume than coal. But the other downside is it also releases methane. Remember, methane is a greenhouse gas that has 24 times more warming potential than carbon dioxide. So if this methane gets into the atmosphere, it is a problem. But fracking is a process that makes this cheaper. So natural gas can be more cheaply obtained through the process of fracking, but fracking will have other impacts, most notably water pollution, habitat fragmentation, and seismic activity. So what is fracking? Fracking is another word for hydraulic fracturing. That is where we are taking a liquid and injecting the liquid down beneath the aquifers into a layer of shale. And shale is just a sedimentary rock. And what is happening is it is cracking that rock, or fracturing that rock, and then in that rock, in those fractures, there will be little bits of methane and natural gas that are released. And then that is pumped back up to a well where it is then collected, this natural gas, and distributed again. So what happens is they will pump down this liquid. And a lot of times this is, liquid is reused. This liquid will fracture the rocks. And the liquid contains natural gas, which is then distributed for use. Now, every time that this fracking liquid, which is predominantly water, but other chemicals may be present in it, when this fracking liquid is used repeatedly, it becomes more and more concentrated with pollutants. So that is a very big problem, and it can contaminate the groundwater, because if you notice, it's going underneath the aquifers. But it's also going down into the layer of rock, and this rock is sedimentary rock, but it also will crack easily. So in areas where you've had fracking, you can see a higher instance of earthquakes. So that is another major problem. Also with the fracking, there is some habitat disruption because a lot of times this natural gas is transported via a pipeline. So we have safe energy and we have clean energy. Now, this is something I found from, again, this website, Our World in Data. So the safest means the amount of deaths that will occur either from the mining or the acquisition of these materials, or from any effects from their combustion. And the cleanest refers to the greenhouse gas emissions. So if you notice, coal is by far the deadliest and the dirtiest of the energy sources. Oil is not far behind. Natural gas has a lot of emissions, and this is because of the methane that is involved, but it's a lot safer if you notice. And it's a lot safer than also biomass, which would be like trees, like wood combustion. And this is because you're releasing particulate matter and carbon monoxide into the home, which people can suffocate and die. But if you notice, our renewable sources are much, much cleaner and much, much safer. In fact, there is Even though you think about nuclear energy, we'll talk about nuclear energy in the next video, but nuclear energy, it's one of the safest methods of electricity generation. Okay, so there hasn't been that many people that have died. I mean, there has been, but it's many fewer deaths happen from nuclear energy and any of these renewable energy sources than it would happen from fossil fuel combustion. There's a lot of information. Please respond to this check for understanding. In addition, for the FRQ practice, I want you to explain how fracking can impact the hydrology of an ecosystem. I hope that this video is informative. I thank you for your attention, and I will see you soon.